Good morning, good afternoon, and good evening, everyone. The authors and invited guests, welcome to Technical Session 8A. I'm Sanskriti Kamkar, and I will be moderating this session. On behalf of the Global Knowledge Research Foundation and GR Scholastic, it is my pleasure to welcome you to the 11th International Congress on Information and Communication Technology, that is ICICT 2026, in London, UK. This edition of the conference is being conducted in a hybrid mode. The physical event was conducted on 24th in London, and the virtual sessions have been conducted via Zoom from 25th to 27th February 2026. I hope you find today's session engaging, informative, and insightful. In this session, we have 6 presentations. Each presenter will have 12 minutes for their presentation, followed by 3 minutes for question and answers. I will give a gentle reminder when 2 minutes remain. I request all participants to stay connected until the closing remarks. If you have any questions or updates, feel free to share them in the chat box. I'd also like to apologize in advance for any mispronunciation of names during the session. Now, before we begin, I'd like to introduce you all to our session chairs. First, we have Dr. Deepak S. Sharma, Professor at Datta Meghe University of Higher Education and Research in Wardha, India. He has 16 years of teaching experience and 3 years of industry experience. His key areas of expertise include artificial intelligence, financial analysis, fintech, financial modeling, and intellectual property. Welcome, sir. Would you please like to share a few words with us?
Yes, Sanskriti, may I audible? Hello.
Hello. Yes, sir, you're audible.
Okay. So, first of all, good evening, distinguished guests, esteemed researcher, authors, and participants. It is my great pleasure to welcome you all to the technical session 8A of the 11th International Congress on Information and Communication Technology, that is ICICT 26. I extend my sincere gratitude to the Global Knowledge Research Foundation, GR Scholastic or LLP, and the organizing committee for giving me opportunity to serve the session chair for this prestigious global platform. Here, ICT has grown into the impactful international forum, bringing together researcher, academician, industry experts, and young scholars from across the world. The overwhelming participation from more than 50 countries reflects the global relevance of information and communication technology shaping the future of society, industry, governance, and education. Today's session represents the true spirit and of interdisciplinary innovation. ICT is no longer confined to computing alone. It drives transformation in e-education, e-agriculture, rural development, then inclusive technology, mining application, and various engineering and managerial domains. So, as a session chair, my role is to facilitate a meaningful academic interaction. I look forward to the engaging with authors through thoughtful questions and scholarly discussion that will enrich the session. Let us make the session intellectually stimulating, professionally enriching, and globally collaborative. With that, I officially begin technical session 8A. So thank you, and I wish all present the very best. Over to you, Sanskriti ma'am.
Thank you, sir, for encouraging words. Next, we have Professor Emmanuel Samuel Swale, Senior Lecturer at the University of South Africa, specializing in higher education, education technology, and adult education. His expertise also includes information systems, business informatics, and software engineering, with a focus on integrating technology and innovation to enhance learning and professional development. Now let's begin to the presentation. Our first presenter is Tariq Huda, presenting Bridging Privacy and Performance, a hybrid LLM agent for security operations.
I'll be sharing my screen. So do you see my screen?
Yes, it's visible.
Okay, perfect. So, good morning, everyone. Thank you for being here. My name is Tark Rada, and today I'll be presenting our paper titled Bridging Privacy and Performance in Hybrid LLM Agent for Security Operations. So, this work addressed one of the most critical challenges facing modern security operations, centers or SOCs, what we call SOCs. How to leverage the immense power of modern AI without compromising the confidentiality of our most sensitive security data. So, first, let's start with the context. So, we are witnessing a paradigm shift in security operations. Large language models are promising to revolutionize how we handle the deluge of alerts in a SOC. So from summarizing complex logs to drafting incident reports, tools like Microsoft Security Copilot are showing us that AI can significantly reduce the workload on our security analysts. So the goal here is clear, is to reduce the time to insight and help analysts focus on real threats rather than noise. However, we face a critical dilemma. We usually have two choices. The first option, option A, is to use high-performance cloud LLMs. These models, such as GPT-5, such as Claude Opus or Sonnet, offer superior reasoning capabilities essential for understanding complex attack vectors. But sending internal telemetry, intellectual property, addresses, property code to a public cloud pose a massive risk. We've already seen high-profile incidents where sensitive data leaked into public models. And the option B in the other side is to use local on-premise models. These are safe. The data never leaves your perimeter, but typically smaller open source models range simply lag behind top-tier models when it comes to the complex reasoning required for intricate security investigations. So they struggle with the nuance needed for a tier 2 or tier 3 analysis stack. And this isn't enough. It's not just a technical preference, it's also a regulatory necessity. So bodies like the European Data Protection Board have explicitly warned against indiscriminate data sharing with AI providers. So they recommend strict anonymization or pseudonymization before any data touch a third-party API. They leave us with a gap. How do we access the intelligence of the cloud without exposing our data? So this is the problematic of our paper. So looking at the related works, the field is moving fast. So we've seen projects like Cgent, which use GPT-35 for log summarization, and specialized models like GPT-2C for parsing honeypot logs. We are moving away from the era of manual rules and older deep learning models like DeepLog towards generative AI. However, most of these solutions either assume the data is safe to share or they run entirely in the cloud. On the privacy side, we have traditional de-identification techniques. Neural models can strip names and IPs, but naive redaction often destroys the utility of the data. If you redact a file completely, the AI doesn't know if the user accessed a harmless distinct file or sent it to password database. So we also have local only architecture like private GPT. These are great for privacy, but as mentioned, they sacrifice the advanced reasoning capabilities of frontier models. They avoid data egress entry, but miss out the performance we need for complex threat. And finally, we must also look at the rise of agentic AI. So systems like React and Trueformer have shown that LLMs can do more than chat. They use tools, call APIs, and execute actions Our work built on this trajectory. We identified that while there are privacy tools and there are agent tools, there are no cohesive architecture for privacy-preserving agents that could autonomously investigate threats while guarantee that the sensitive data remain on-premise. So this brings us to our contribution, an hybrid LLM agent architecture. So we propose a two-tier system. First, a local guardian. It's a local LLM that sits on-premise. It handles sensitive data anonymization and tool execution. And the second is a cloud reasoner, a powerful model such as GPT or Claude that receive only synthesized abstract scenarios. We treat the cloud model as completely entrusted, so it never sees the raw data. Only the logic puzzle were present to it. Here is the high-level architecture. So the user query enter the local LLM. The local LLM identifies sensitive entities and swap them for placeholders. These placeholders are mapping in a secure ephemeral key value store. The standardized prompt is sent to the cloud. The cloud reasons and respond. The local agent then de-anonymize the response before showing it to the analyst. So with this mapping, the data never leaves the local environment. It's worth mentioning that the use of a local LLM will allow us to go beyond the simple anonymization of the entities, because it lets us also perform what we call a synthetic anonymization, so that we won't lose the meaning of some files. For example, if a user accessed a password file, if the term password is replaced with a generic name to refer to a file, the LLM will not, the reasoning LLM, which is the cloud LLM, will not consider this as a threat, because we have to keep the meaning of the file even after anonymization. So, and this is very important because it allows the cloud LLM to see the structure of the attack. It can see, for example, user one logged in from IP1 and then accessed file one. It can detect the pattern of lateral movement attack without even knowing who is user one or what is the content of file one. So we use a combination of regex for speed and local LLM for complex entity recognition. And let's walk through a concrete example. So from our paper, imagine a log entry shows admin accessing secrets, plans, docx. So the local guardian transformed this into user one accessed F1. So the cloud LLM analyzed the abstract sentence. It responds access to F1 by user one is suspicious. So the local system then swaps the values back. The analysts see the full coherent insight, but the cloud provider, the cloud LLM provider only see the placeholders. And this go beyond simple question and response. This is an agent, so it have the ability to interact with the environment. So if the cloud LLM says, I need to see IP1, if IP1 has failed logins, so the local agent interpret this, it look up the real IP for IP1, execute the same query locally and get the results, sanitize those new results and feed them back to the cloud. So this allows for an iterative investigation loop. And to prove this work, we conducted a rigorous evaluation. So we took 20 real incident tickets and had them and had 3 senior SOC analysts evaluate the output blindly. So they compared the raw output, the standard cloud LLM, against our hybrid output. We measured the utility, fact, coverage, and clarity based on a defined scoring. And the result was compelling. So on the utility score, out of 5, the hybrid model achieved 4.56 compared to the raw models 4.61. So this is negligible difference of just 0.05 in terms of fact coverage, and we only missed 1.4 of the fact compared to the cloud-only model. And in 18 out of 20 tickets, analysts rated our privacy preserving output as equal to the non-private version. So this proved that you don't have to sacrifice performance for privacy. And on the privacy front, we achieve 99% precision in redaction with absolutely zero data leakage to the cloud in our test set. So, and the overall cost of all this is that the system adds about 2 seconds of latency per query. In a SOC environment where an investigation takes minutes or hours, waiting an extra 2 seconds for total data sovereignty is a trade-off most organizations are happy to make. And why it works? So the cloud model detects the pattern without needing the identification. And looking to the future, we have several exciting directions. First is the adaptive routing. So right now we send all most reasoning tasks to the cloud. In the future, we want the local guardian to assess the difficulty of the prompt. If it's a simple request, so that he can handle it locally, or if it requires deep reasoning, sanitize it and send it to the cloud. So this will optimize both cost and speed. Second, we want to harden the privacy layer even further. We are exploring stateless transformation, such as format preserving encryption. So this would allow us to remove the local key value stored entirely, simplifying the architecture. So we also want to improve how we handle implicit context, sensitive information that isn't a named entity but is inferred from the text. And finally, we plan to scale our evaluation. We want to test this on multi-organization datasets and across different languages to ensure robustness. We also plan to integrate retrieval augmented generation pipelines to handle massive log files that exceed the standard context windows of LLMs. And in conclusion, our work demonstrates that the trade-off between privacy and performance is not absolute. So by treating the cloud as a trusted reasoning engine and employing intelligent structure preserving anonymization, we can build SOC agents that are both powerful and compliant. So we have empirically proven that you can achieve cloud level utility without zero data leakage. With zero data leakage, organizations no longer have to choose between being secure and being smart. So thank you very much for your attention. So now I'm ready to get your questions.
Yes, Mr. Tariq, I have one question. Can you formally model the trade-off between anonymization depth and reasoning accuracy and identify an optimal balance point?
I didn't get the question.
Can you formally model the trade-off between anonymization depth and reasoning accuracy and identify an optimal balance point?
Yes, indeed, there is a correlation between the analyzing depth and the reasoning or the analysis accuracy. So if you try to analyze a lot of data, for sure the accuracy of the investigation will change. However, we didn't address this this correlation in our research paper.
Okay, that's good. One last question for you. In mission critical environments, how should organization prioritize intelligence versus confidentiality, and where does your system realistically stand?
Actually, as you mentioned, in critical environments, they can't afford to send the data to the cloud. But if they still want to leverage the capabilities of strong cloud LLMs, so this solution is for them is to leverage a local model. So most of mature organization can now afford some small local models. So the local models will be used to anonymize the data so that no sensitive data is sent to the cloud.
Okay.
So this is how they can leverage this solution.
Okay. That's good, Tariq. Thank you. All question from my side is done. Thank you. Thank you, Tariq.
Thank you very much for your
Yes.
questions.
No.
Thank you, Mr. Tariq and Sharma. Next, we have Sebastian Diaz presenting From Centralized Data to Data Mesh, a case study of scalable data management.
Hello, everyone. My name is Sebastián Díaz, and today I will present our work from centralized data to data mesh, a case study of scalable data management in a startup. This research was co-authored with Matias Grego. The volume of data is fast-growing startup increase a pace much higher than their capacity to manage it efficiently. In the current context of digital transformation, data has become one of the most important assets for defining strategies and making decisions. This accelerated expansion raises technical and organizational challenges, especially regarding governance, quality, availability, and the scalability of information access. Our main question is, how can data mesh improve scalability and operational efficiency in startup environments? For decades, the data warehouse was the predominant approach to enterprise data management. This model enabled the integration of information from different sources into structural central repository, optimized for querying and analysis. However, the data warehouse showed limitations when dealing with unstructured and constantly changing data environments. Since its rigid and highly governed design makes it difficult to incorporate new source and format. With the rise of big data, data lakes emerged as an evolution intended to overcome these limitations. A data lake centralizes data from multiple sources in its original format, offering flexibility to store structural, semi-structural, and unstructural information. However, in practice, many data lakes become monolithic repositories. In congruent context, ingestion, modeling, and delivery often depend on a central team, creating bottlenecks and long waiting time. In response to the limitation of centralized models, in recent years, the concept of data fabric has gained popularity. This approach seeks to integrate distribution data through unified virtual layer that automates process of discovery, access, integration, and governance of information. But it is mainly technology solution and often does not fully solve the organizational problem of data ownership. The concept of data mesh is inspired by service mesh model, which describes how microservices interconnect within a distribution architecture. Just a microservices transformed monolithic application by dividing them into smaller scalable and independent components. Data mesh proposed a similar transformation in the realm of data, admit and replacing monolithic data management architecture with a more distributed, agile, and adaptable structure. Many organizations have adopted approaches such as domain-driven design and microservices-based architecture, where development teams are organized around well-defined business domain. These teams often have a deep understanding of their domain, including the information and analytic requirements associated with it. However, in a centralized data model, they still depend on a central data team to access and process the information they need, perpetually inefficiencies and dependencies. In response to this scenario, data mesh proposes a structural solution, transferring the responsibility for data from the certain team to the domain teams themselves. This means that each domain becomes the owner of these data products, assuming responsibility for the quality, availability, governance, and maintenance. In this way, the teams that best understand the business context are also those who model, maintain, and often their data as reusable products within the organization. Data mesh is based on four pillars. First, domain-oriented ownership. When each domain team is responsible of its own data products. Second, data as a product. Data must be documented, reliable, and usable like a software. Third, self-serve data platform to publish and consume data without depending on a central team. And fourth, federated governance. Shared standards and policies for security and interoperability. Our case study is a fast-growing startup in the automotive sector, when data is critical to scale operation, improve decision, and stay competitive. However, like many medium-sized company and technology startup, the company faced multiple challenges derived from absence of consolidated data department and a clear strategy. On this slide, the key point is the diagram that shows our previous situation. The architecture consists an operational layer composed for two relational database and analytical layer, based on their replicas which were consumed via reported system, in this case, Metabase. The data flow presents a limitation at all stages. Storage relied on the transactional database designed to support daily operations without considering historical traceability or versioning of information. At the level of integration and modeling, the dependence on manual and centralized process increase the operational workload and generate delays in the delivery of critical information. Finally, at the consumption stage, business and product teams had not to rely on a small group of technical specialists to access the data, which limited autonomy and slowed down innovation. To address the challenge, a data mesh approach was adopted to decentralize data management, empower domain teams, and reduce reliance on a central team. This model provides a sustainably scalable and cloud-agnostic framework, grounded in distribution governance, domain ownership, and self-service. The solution design focuses on applying the principle of data mesh approach, considering both the business needs and the limitation of existing centralized model. On this slide, I show the proposed architecture. It has three layers. Operational layer, composed of transactional database and systems that support critical business services. Analytical layer, responsible for ingestion, storage, initial preparation for consumption. And governance layer, focuses on centralized management of permissions, traceability, and auditing with distributed access for domain teams. This architecture relies on standards and convention that can be implemented in any cloud environment. In home implementation, the backbone service with S3 storage, Glue for ingestion, and catalog, lake formation for governance, and database migration service from replication from relational database to S3. Now the results, first, cost optimization. Using S3 as the main analytic storage plus Parquet and Athena, reduces storage and query costs and avoided upfront infrastructure provision. This table shows the cost of the previous and new architecture. The cost of each service we collected from Amazon Web Service, of course. In our cost comparison, the total monthly cost went at about $606 to about $151. Second, operational efficiency. AWS Glue, automation reduce manual work in ingestion, transformation, and cataloging. This enables near real-time availability of data products with minimal human intervention, unlike formation, centralized policy with federated access. The figures illustrate the operational optimization, demonstrating reduced manual intervention and simple process. Previously, enable a new BI asset required multiple teams. El development exposed database, central data team ingested and modeled it. DevOps created replicants and management permission, and Operation BI connected each replica to Metabase to build dashboard. With data mesh, the domain team simply publishes a Parquet data product with a contract. DevOps catalog it with the standard policies, and Operation BI reused a single Metabase connection for modeling and dashboard. This removed the central team from the path, reduced the stakeholder, and accelerated delivery. Third, horizontal scalability. Instead of one ever-growing database, we split data into smaller, domain-specific like microservices. This improves performance and simplifies operation as a company grows. To validate the approach, we will a predictive model for credit approval, which is a critical process for sales, conversion, and growth. The model used multiple domain datasets, so thought image, such as customer data, vehicle data, credit condition, channels, etc. The benefits were simplified access, a scalable integration for new store, and standardized consumption across different teams. We also improved self-service dashboard before Metabase connected directly to multiple RDS replicas, which increased credential management and made cross-domain joins difficult. With our approach, dashboard use a single Athena access point, with Parquet products in S3 cataloged include a governed like formation. This provides unified access, enable cross-domain analytics in one query, and avoid changes in Metabase when the relational database is fleet span. In conclusion, data mesh provides to be a viable and effective alternative to centralized data management in a fast-growing startup. Our case show it can work not only for large enterprise, but also for medium organization facing complexity in governance, access, and scalability. As a future work, we want deeper empirical evaluation of organization impact in structure, skill development, and cross-functional collaboration. And thank you for your attention.
Yes, may I audible?
Yes, sir, you're audible.
Okay, I have a question. How do you prevent data silos from re-emerging within domain-specific bucket while maintaining domain autonomy?
Mm. I'm sorry, I am still learning English, and so I understand your question.
Sorry, you asked about how to prevent what? I couldn't catch the question.
Hello. Yes, may I audible?
Yes, sir, you're audible.
Hello.
Sir, you're audible.
Yes, my question is, how do you prevent data silos from re-emerging within domain-specific bucket while maintaining domain autonomy?
Okay, how to prevent the data loss between the different domains? ¿Cómo prevenir la pérdida de datos en los diferentes dominios?
Eh, Para eso hay que, los equipos de dominio deberían ser bien rígidos con las políticas a aplicar, donde deberían mapear cada uno de sus esquemas de datos y así ir replicando constantemente estos datos.
Okay, every domain team have to be strict with their domain, with the data inside this domain, and everyone has to have a mapping about what is the data inside the domain and how to apply the politics in the domain.
Okay.
Thanks for your question.
Yes, yes, thank you. Yes, Sanskriti, or from my side.
Thank you, Mr. Days and Dr. Sharma. Next, we have Tatiana Musenko presenting machine learning algorithms for cybersecurity of UAV-based environmental monitoring systems, attack simulation, and security architecture.
Thank you. Just a moment. Mm, так вот. Yes. Dear colleagues, members of the community and guests of conference, my name is Tatiana Nosenko. I sorry, do you my presentation is?
Yes, it is visible, ma'am. You can continue.
Oh, yes, thank you. Today sorry. My presentation.
Ma'am, is visible. You can continue.
Today, I honored to present the result of research titled Machine Learning Algorithms of Cybersecurity UAV-Based Environment Monitoring System, Attack Modeling and Defense Architecture. The event, the event of February 24, 2022 caused by the Russian Federation aggression against Ukraine radially changed to perception of nuclear of environmental safety. For the first time in history in Operation Nuclear Facility, the Chernobyl MPP became an element of open war. The occupation of the exclusion zone revealed the critical vulnerability of the so-called conserved territories. Interference with the ecosystem of the Red Forest has become especially dangerous. Digging trenches in places where radioactive materials are buried has led to the disruption of protective layers of soil, the raising of radioactive dust increase in the gamma background, and the risk to radionuclides being carried by the wind. Under such conditions, remote methods of radiation control are necessary for an operational response. That is why modern monitoring systems are increasingly using mobile platform based on drones, which allow them to work in dangerous area to quickly obtain
Sorry,
a
ma'am.
detailed.
Hello.
Yes,
Sorry for interrupt you. Your slide is not moving.
slide not moving.
Only motivation and
Yes.
context. That's first slide is
Just now, yes? Just,
yes. This
yes?
is your first slide, no? Okay,
Oh,
you can continue now.
sorry. Сейчас еще раз.
No problem. No
Новый.
problem. Take your time, ma'am.
Um, just moment. Just moment. Заклинило что-то.
You need any help? Any assistance
Uh,
with sharing the screen?
Yes. Just a moment. Oh. Ye- Yes.
Yeah, it's visible now.
Under such condition, м, не знаю, слетает и все. Демонстрация есть. Under such condition, remote method of radiation control are necessary for an operational response. That is why modern monitoring systems are increasingly using mobile platform based on drone, which allows them work in dangerous areas and quickly obtain of detailed spatial picture on pollution. But along with mobility, a new risk appear. Such systems are a full-fledged cyber physical ecosystem, and if data is compromised in this ecosystem, the consequences can be much more serious, serious than just a error in the table. A false map of radiation contamination is a wrong management decision. A wrong decision is a risk to people, and this is where the key question arises. Are classical cybersecurity methods sufficient protect such system? Most research in the field of drones cybersecurity focuses on protection a communication channel, and this absolutely necessary. But all this cryptography protect the container. It does not answer on very simple question: are the measurements themselves placeable? Imagine that an attacker has gained control of the system sensor. It transmits data that is perfectly signed, encrypted, and verified. Cryptography sees nothing, but physically, this data is impossible. This problem became the starting point of our research. Our approach shifts the focus from traditional container protection to semantic integrity, where the analytical engine itself verifies the physical plausibility of the incoming data. We propose the concept of intellectual immunity of the system, where ML implements a zero trust strategy to each received measurement. Architecturally, the system looks quite classic. The drone collection data, transmits it via the secure channel to the cloud, where it is processed, and interactive map is formed for the operator, and the map according to the specified parameters of received by the mobile application. The result of attack surface analysis are shown at this slide. Before building the defense, we must understand the threats. We present a comprehensive analysis of the attack surface mapped across all 4 levels of our system. Onboard system first. Here we face physical hardware interference and navigation attack, such as GPS spoofing, which can trick the drone into reporting incorrect coordinates for radiation hotspot. 2. Data transmission. This involves communication channels that, including men in the middle attack, aimed at intercepting or altering data packets during flight. 3. Cloud infrastructure. This is critical area where we encounter data poisoning, the most sophisticated set, wherein attacker attempt to corrupt the ML model's logic with fake measurement. And the client application. Oh, sorry. Client application. The endpoint of the user. Here the risks include unlawful rights access and API vulnerabilities, which could allow an attacker to gain control over the monitoring dashboard or manipulate of final visualization. This general scheme. Our approach implements the security by design principle. The first echelon is traditional cryptographic protection. We use the MQTT protocol on top of TLS to encrypt traffic, authenticate the server, and ensure message integrity using MAC codes. For device authentication, mutual authentication based on X509 client certificate is implemented. Each data packet is signed using HMAC SHA256. This allows the server to instantly reject modified message. So it first echelon of basic level to trust. But all this cryptography protects the container. It does not answer on very simple question. Are the measurements themselves placeable? We set ourselves to task of building of architecture where ML performs not only the function of analytics, but also the function to protection. That is, the model that built the pollution map must also be able to recognize semantic falsification. Therefore, we added a second echelon, mathematic protection based on ML, deployed at the cloud infrastructure level. At the heart of this level is Gaussian process regression model. Why GPR? Because it is just interpolation. This is not just interpolation. This is a model that studies of spatial structure of the phenomenon. It does not just predict values. It learns to understand how the pollution field behaves. Where gradient naturally arise, how neighboring points are connected, what is the logic of space should be. After training, the model actually forms the digital fingerprint of the territory. And when a new measurement arrives, we check it not only for cryptographic validity, but also for physical consistency with the student picture. If sharp local peak appear without changing the background around it, this is suspicious. If the uncertainty of the forecast increases, this is signal. If the value contradicts this special correction, the system mark it. Thus, the model simultaneously build a map and act as a semantic fuse. To test this idea, we conducted experimental simulation using Python with scikit-learn for Gaussian process regression model. The experimental plan is presented on slide. First, we generated the physically consistent pollution map with smooth transitional of natural hotspot. The model was trained on the data. After that, we deliberately introduced three synthetic anomalies, values that significantly exceeded the maximum and did not correspond to their syringes. The result was indicative. The simulation results are present in figure. All three injection points were detected. At the same time, natural local maxima were not misclassified as attacks. This confirms that the uncertainty map is a reliable indicator of data compromise. A generalized architecture of defense in-depth system level attack surface and corresponding defense mechanism is presented on the slide. The novelty of this research is now integrate security directly into analytics pipeline. We do not add separate heavy-duty introduction detection system module to the drone. Instead, the same algorithm that provides the environment analysis also provides the security verification. This dual use of ML models minimize the computational overheat and maximize the defense in depth. Of course, such system involves trade-offs. On the edge, the encryption adds to moderate a load to the CPU, which slightly increases latency. However, by moving the GPR modeling to the cloud, we preserve the drone's battery life. This is deliberate architectural choice. We use the limited onboard power for flight and basic signal while utilizing the unlimited power of the cloud for deep semantic analysis. This ensures we don't sacrifice mission time for the sake of security. Of course, the approach has limitation. GPR is computationally complex. False positive false positive are possible. The model need retraining. That is why the computationally a heavy part of is moved to the cloud so as not to overload the drone. In the next place of our research, we plan to implement LSTM network, long-term memory models, to analyze temporal pattern. This will allow us to detect not just special anomalies, but also sophisticated attacks that evolve slowly over time. We also aim to test this architecture as a physical prototype in the file to
Excuse me.
measure its real-world radio interference.
Excuse me, ma'am.
Yes.
This is just a gentle reminder that you only have 1 minute left, so could you please wrap it up?
Just I'm sorry, I'm having some technical. Just a minute. Could you please repeat the question more slowly?
Okay. This is just a gentle reminder that we have 1 minute left for your presentation.
How? Repeat, please repeat.
May I audible?
Yes, sir.
Yes. My question is, how does your architecture mitigate man in the middle and phishing attack at the client application level?
Phishing attack?
At the client application level.
Level. Various machine learning algorithm can be employed to radioactive anomaly detection, depending on the specific research goals. As process regression, Gaussian process regression as a Bayesian method is ideally suited for spatial modeling. It provided not only prediction of radiation level, but also creatingly quantification. This is critical for undefined area where data might be compromised or insufficient.
Okay, thank you. Thank you, ma'am.
Thank you.
Yes.
Now we have Kautar Bumalik presenting personalizing microlearning, retrieval augmented generation.
Hi everyone. Could you hear me?
Yeah,
Yes,
you're
ma'am.
audible.
Yes, ma'am. You can continue.
Thank you for you all. My name is Kautar Boumalk. I am from Ibn Zohri University. I'm here to present my paper titled Personalizing Microlearning with Retrieval Augmented Generation RAG. We are here following the outline. This outline. First of all, we are going to present background of our paper, the related work, the general pipeline of generating micro content with the retrieval augmented generation. That we are going to answer some frequent questions and see some future directions and conclusion. So, as you are seeing here on the left, the well-known forgetting curve proposed by Hermann Ebanguis. It illustrates how learners rapidly lose information over time when there is no reinforcement or reviewing. This natural decline in memory retention highlights one of the main challenges in traditional learning approaches: information overload and lack of sustained engagement. So, as a solution and response to this challenge, we are proposing microlearning that breaks down complex content into small, focused, and manageable learning units. By delivering short and targeted learning activities, it reduces cognitive load and facilitates better retention. As generative AI represents a transformative opportunity for microlearning, as it enables dynamic creation of short, personalized, and context-aware learning units. By leveraging advanced language models, educational content can be automatically generated, simplified, adapted, and reinforced according to each learner's need. This synergy allows microlearning to move beyond static content delivery toward intelligent, adaptive, and learner-centered experience. So, the question that we have here is: how can microlearning systems effectively personalize content to address diverse prior knowledge, learning preferences, and engagement patterns while minimizing AI-generated hallucinations? Secondly, how can adaptive learning approaches dynamically respond to learners' evolving needs and contexts rather than relying on static rule-based or recommendation-driven mechanisms? And last, how can AI-driven microlearning environments ensure the delivery of precious, context-aware micro content while maintaining relevance, accuracy, and meaningful learner assessment? So the objectives of our paper is to investigate how RAG can address limitations of existing recommendation-based personalization approaches, highlight the potential of RAG to increase flexibility, adaptability, and learner engagement in microlearning environments, demonstrate how combining retrieval mechanism with transformer-based generation model can improve precision and contextual relevance. Last, provide a conceptual foundation for future research and development of next-generation AI-driven personalized microlearning system. So here we are going to present some concepts related to microlearning. First, we have micro content, means small focused learning units designed to address a single objective or concept at a time. Micromedia, short format digital media like micro videos, micro infographics, or micro broadcasts, micro interactive snippets used to deliver micro content. Microlearning attributes one of the main characteristics of microlearning is brevity, focus, flexibility, accessibility, just in time, and these attributes make microlearning adaptable to modern learners' limited time and attention spans. Micro assessment, brief targeted evaluation activities embedded within or after micro content units. So here some of related work, we have AI-driven personalized microlearning. The AI automates micro content creation and dynamically adapt learner experience based on learning behavior and progress. Machine learning personalization that predicts learner needs, deliver tailored feedback, and regulates pace to optimize cognitive load. We have the large language models that generate adaptive explanation activities and learning paths aligned with individual learning levels and contexts. For the retrieval augmented generation technology, we have a hybrid architecture that combines external knowledge retrieval with generative language models. Grounded generation response are anchored in retrieval documents to improve accuracy and relevance. We have flexible variants RAG sequence that conditions the entire response on one retrieved document sampler, less flexible, but RAG token dynamically retrieves different documents during generation, more flexible and multi-source integration. For advanced evolution, we have adaptive and modular RAG systems that optimize retrieval and reasoning dynamically. For some applications of RAG in microlearning, we have the RAG transform static lessons into personalized on-demand micro-units and personalized assessment. It generates adaptive quizzes and targeted review materials. For real-time adaptation, content evolves continuously according to learner progress. For emerging practical uses, query-focused summarization for automated micro-lessons and personalized assessments and target review materials, adaptive feedback, learning gap detection, and spaced repetition support. Here we have a comparative table that compares traditional microlearning versus the RAG-based microlearning. Traditional microlearning in general relies on predefined content that is carefully designed and curated in advance. The materials such as short videos, quizzes, and infographics are created manually and delivered proactively to learners. While this ensures quality control and reduces the risk of misinformation, updating the content can be time-consuming and costly. Personalization is usually limited to predefined learning paths, and interactivity is often restricted to programmed exercise. In this model, learners mainly follow a structured pathway designed by instructors. In contrast, RAG-based microlearning integrates a generative AI models with an external knowledge base. Instead of relying only on created materials, it retrieves up-to-date information dynamically and generates response in real time. This allows for highly personalized, context-aware learning experience. Learner can ask follow-up questions, explore topics freely, and engage in a dialogue-like interaction. The system adapts to their needs rather than forcing them into a fixed path. So, overall, this shift from traditional to RAG-based microlearning represents a move from static instructor-controlled content delivery toward dynamic, adaptive, and learner-driven educational experience. So here we are going to present the general pipeline of generating personalized micro-content with the RAG. As first step is the user input with the learner profile. Here the process begins when the learner submits a query, a topic of interest, or a request for guidance. Alongside this request, the system considers the learner profile, which contains information such as knowledge level, preferences, and past performance. This combination ensures that personalization is present from the start, getting later stages to adapt both the difficulty and the style of the generated macro content. So let the learner query be Q and their profile P. Knowledge level, preferences, past performance. The input vector RAG is defined X equals F sub-users Q and P in R power D. Here, if user encodes both the query and the learner profile into a semantic vector. Then we have the second step is the pre-processing, where in this phase, the pre-processing techniques clean the text by removing irrelevant symbols, normalizing format, and tokenizing the content into manageable linguistic units. The goal is to create a uniform and machine-readable representation of the material, ensuring that sequence steps such as segmentation and embedding operate on consistent, high-quality text. Formally, let the route X document be D equals the sequence of D1, D2 up to Dn. Each document D E pre-processed through normalization and tokenization, producing a sequence of tokens. T sub E equals tokenized normalized. D sub E equals the sequence of V1, V2 up to Vm, where T sub E is the tokenized output of the document D sub E, and W sub G represent the G token, which can be a word, subword, or relevant symbol. M is the total number of tokens in the document. The third step is the segmentation. After cleaning, the text is divided into smaller semantic units, often called microchunks. Each unit typically represents a single concept, definition, or example, making it more suitable for retrieval and recombination. Segmentation respects natural boundaries such as paragraphs, hidden, or logical sections. This step is critical because it aligns with micro-learning principles. Knowledge should be broken into atomic, easily digestible parts that can later be tailored to the learner's needs. Each pre-processed document T-sub-E is divided into micro-chunks C-sub-E and G.
Sorry, ma'am, for your interruption. Jump with adaptive generation. That is point number 6.
What?
You can jump with adaptive generation. That is point number 6.
Okay.
Or last, user output. What is the user output?
The user output is the answer, the response, the query. It may be a lesson or summary or a quiz or visualization. That's it?
Yes, this one.
Okay. So this is the last one, which O is the final output. It may be a lesson or summary or a quiz responded to the query of the learner or the user. So why RAG is a good fit for micro-learning? RAG provides a dynamic and content instead of size material, enhance accuracy and contextual relevance through retrieval and LLM integration. It supports personalized and learner-centered micro-content delivery, ensure reliable, verifiable, and trustworthy outputs, increasing learner confidence. So what are the key considerations when applying RAG to micro-learning?
Ma'am, what are your ultimate conclusion of entire research?
What?
Conclusion of your entire research. Conclude.
This is the conclusion. I have thoughts here and some future directions, which is adaptive and real-time personalization. And here, multimodal micro-learning with RAG, with extend RAG beyond text to integrate video, audio simulations, and interactive content for richer multimodal micro-learning experience. And so that's it. Thank you and welcome for your questions.
Yes, I have only one question for you.
Okay.
How is adaptive generation evaluated to ensure alignment with the learner profile and cognitive level?
What's your question exactly?
How is adaptive generation evaluated to ensure alignment with the learner profile and cognitive level?
We are making some threshold and compare their overall score with that threshold. See if this really respond to the requirement of the user or not.
Okay, ma'am. Thank you. Thank you from my
You're
side.
welcome. Thank you.
Thank you, Ms. Bhumala
You're
and
welcome.
Dr.
Thank you.
Sharma. Now we have Chen Trong Kwok Lei presenting phishing detection using email header and content analysis.
Hi, can you hear me?
Yes, you're audible.
And do you see my screen?
Yes.
So, okay. So, good morning, distinguished member from the board and fellow scholars. My name is Ting, and I'm honored to represent our research team from the University of Economics, Ho Chi Minh City. Today, I will present our study, phishing detection using email headers and content analysis. This project was collaborative efforts with my college, Viet Thang, Gia Tính, Anh Vũ, and Gia Khang. So, about the landscape, phishing has evolved from single technical intrusions into sophisticated physical manipulations. We are seeing a dangerous shift in cyber attacks Notably, phishing targets social media platform surged from 18.9% to 42.8% in the late 2023 alone. While automated tools are vital, the human firewalls remain the most vulnerable element. This attack leads to serve financial damage and, more importantly, a fundamental erosion of our customer trust. So we give the solutions. So for the proposed solutions is the integrated analysis system to encounter this risk. Our approach uses a multiple stage of pipeline that merge the strategic digital security with deep learning. The core strategy here is the result optimizations. Our system rapidly filters obvious threats using fast algorithms while reserving heavy computational power only for the most complex cases. We have developed this a command line utility for use like for real-time analysis. So there will be the four-phase pipeline. The IAS framework stratifies data through four rigorous phases. Phase one is about employs keywords and regular expression to identify the red flag, like urgent, mitigating about 20 to 30% of obvious threats within the latencies of just 1.5 to 1 milliseconds per email. Phase two is about machine learning. Utilize the random forest for probability scoring instant falling within the gray area of 1.5 to 1.9 are flagged as suspected. About the deep learning phase is phase three. This is the heavy lifting layers where the BERT performs an intensive analysis of the semantic context of suspected case. About the integrations, a pipeline class directs the operational flows from rules to rainforest and BERT. So to validate our system, we utilized a publicly accessible dataset from the Zendonode comprising 2,000 total emails. We maintain a balanced compositions of 1,000 email phishing and 1,000 safe sample to prevent algorithmic bias. An 80-20 partitioning was applied with 1,600 emails for training and 400 for testing. The dataset includes 21 attributes spanning original content, statistical features, and rule-based flag. So the IAS achieved a high accuracy of up to 96.5 up to 96.25% on the datasets. Most significantly, our system reached the record of 1 for phishing. So why are these results nearly perfect? From an academic perspective, achieves a record of 1 and AUC of 1 with random forest might involve concern regarding overfitting. However, this is we call a calculated strategic trade-off. We are prioritizing safety because in the cybersecurity, the cost of false negative is catastrophic. We intentionally tune the system to ensure zero phishing attempts bypass the filter. And even if leads to a marginal 3.75% of false positive rate. The model conversions. The Zendonode dataset contain highly representative phishing pattern. The synergy between the phase one rules detections and the BRT semantics understanding allows the model to converge perfectly on the specific malicious features. So up to the analyzing the false positive, the cost of absolute recall is 15 false positive. This occurs due to the rule-based oversensitivity to term the common in legitimate business communications. Nevertheless, the model discriminations remains superior. Random forest achieve an AUC of 1 and the BERT reach the nearly 1. Both models demonstrate a nearly perfect ability to distinguish between the phishing and the safe instance across the nearly every threshold. To overcome the black box of a natural AI, we integrated the explainable AI. By analyzing the extension score, we demonstrate that the terms of password and urgent drive the result. Our CLI application allows users to feed content directly into the terminal to receive classifications, confidence rates, and specific reason for result real time. So for the conclusions, the AIS maintain a superior processing speed of 5 to 10 milliseconds per email. Future research will focus on the deeper integration of email headers and expand dataset diversity to enhance model generations. And thank you for your time, and I'm now open for your academic questions.
Yes, it was a very nice presentation from your side. I have one question which are correlated with experimental result. With a recall of 1 for phishing, how does the model perform on more diverse or real world imbalanced data sets?
I am not hearing that not clearly. So can you repeat it, but just slowly?
Yes, you show us experimental result.
Yeah.
Your experimental result. From that slides, I have one question for you. With a recall of 1.00 for phishing, how does the model perform on more diverse or real world imbalanced data sets?
So
Okay. Okay. One small question from my side again. What performance gains does the multi-phase approach provide compared to using only deep learning, that is BERT, end to end?
so can you repeat the second question?
My question is,
Yeah.
what performance gains does the multi-phase approach provide compared to using only deep learning, that is BERT, end to end?
Okay. So so in mission critical sector, we prioritize the local first approach. Our tool is CIL utility, mean it can run entirely on an organization internal servers without sending data to clouds. We only use deep intelligence for 20% of the case are truly suspicious. This way we can get the best detection power power while keeping the 80% of routine emails away from the complex processing.
Okay. Thank you.
Thank you, sir.
Thank you, Mr. Lay and Dr. Sharma. Finally, we have Paula Cristina de Almeida Marquez presenting Strategic Governance and Crisis Readiness, Longitudinal Insights on AI BSc Integration in Healthcare. Do we have Ms. Paula with here? So that is all the presentations for today. I sincerely thank all our authors for their excellent presentations and valuable contributions to this session. I also extend my gratitude to all participants for being a part of this international conference. I hope this session was informative and insightful. On behalf of the ICICT team, thank you for your continued support during the 11th edition of ICICT, as well as all the previous editions. We look forward to welcoming you again for the 12th edition in 2027. All presenters will receive their digital certificates via email within 2 working days. The publication is expected to be available within 7 to 8 months. We kindly request your cooperation with the ICICT 2026 team during this process. I would also like to thank our session chair, Dr. Deepak S. Sharma, for effectively chairing this session.
Thank you,
We
ma'am.
now present a token of appreciation. So would you
Yes.
please like to
Thank you.
share any closing comments?
Yes. Thank you, ma'am, for this appreciation.
May I please request everyone to turn on their camera so that we can have a quick snapshot of the session? Thank you everyone for joining us today.
Thank you, dear all. Thank you, ma'am.
Thank you, sir.